Well, hello there. Today we are going to talk about mutually exclusive and mutually exhaustive events. So, let's get started. This is my whiteboard. I'm poor bastard, you can see that. So, imagine that this is a sample space, this box right here, and we have two events. Let's say this is event A and this is event B. Now, as you can see, event A and event B right here, they don't have any intersection. They do not they don't collide over each other. You know what intersection is, I hope. So when two events they have no common elements, that's when we say that it's mutually exclusive. They are two mutually exclusive events. So for this sample space, events A and B are mutually exclusive. So you can also say that in this P of A intersection B, this is P of A intersection B, I hope you can see this, equals 0 because they have no intersection. So we can say that for another sample space, for this sample space you can say that events A and B have an intersection. That means they do have common elements. That means that this is not a mutually exclusive event. Here A and B are not mutually exclusive. So we can say that this is mutually exclusive, but this is non-mutually exclusive. I hope you can read this. I have shit handwriting. Now, for this for this sample space, events A and B are mutually exclusive, but for this they are not. So let's take another example of for exhaustive. So let's take another example. We have two events A and B. This is a sample space, and this is events A and this is event B. You can see that the even A and B together, they just take up the whole of this sample space. Like there is no empty space. But if you look here, it's just this circle. Event A is just this area, and event B is just this area, and the rest of the sample space are some other events which are not specified or defined. But here you can see that this is event A, this is event B, both of them they take up whole of the sample space, and that's when two events are mutually exhaustive. You can say that when they take up the whole of the sample space, when there is no empty space. That's how I define it. You can find the correct definition. I don't remember the correct definition. You can find it on the internet. But just for a layman example, this look at this. When two events, they just take up whole of the sample space so much so that there's no, no events come under, you know, an empty. No events go unnoticed. Let's say unused. That's when we say it is mutually exhaustive. Now, we can also say that a mutually exhaustive events can have common elements. You know, imagine this is A and B, and they have common elements. They intersect with each other, but this doesn't. So what can we say? That this is also mutually exhaustive because they take up whole of the sample space. This is also mutually exhaustive, but this is mutually exhaustive at the same time. This is mutually exclusive because they don't have any intersection, but they have an intersection. So what can we say? That this is mutually exhaustive and mutually exclusive. But this is mutually exhaustive but not mutually exclusive. that was that it. I hope you guys understood well. If you don't, I'm sorry. You can just comment down below. If you want to praise my work, you can do that. If you want to just shoot me down, you can do that too. Because of the, I know that this is my first ever time I took a class. Make sure you subscribe. Bye.